Welcome back, Pre-Calc. We're going to be investigating 2.5, and some of this might be your reminders from Algebra 2, just the verbs that I use or nouns, whatever the English terms are, might be used differently in this class. But as you recall, what makes something an even or odd degree polynomial is the highest exponent. And that, so as we look at this, this is even because the highest exponent 2 is even. Highest exponent being 4 is even. You can see a lot of these. I'm just going to go through the evens real quick. So then what you do is you look at the exponent that's in front of the highest exponent. Because sometimes we hide the highest exponent in the middle. I just don't do that to you in the notes. So as we look at the coefficient that's in front of the highest exponent, that term is positive. On this one in front is negative. Negative. Positive. So what we're looking for is, as a reminder from Algebra 2, they actually wanted you to use a graphing calculator. I'm not going to do that, but if you were to use a graphing calculator, you may remember from Algebra 2, a positive leading coefficient with an even degree, is going to be going up and to the left and up and to the right. Now I'm just going to put some dotted lines in here because if it's a parabola, if it's a squaring function, it just has that behavior. If it's a quartic, fourth degree, it might have a few turning points in there. But no matter what, if the positive leading coefficient, it is going to be rising to the left, goes infinitely up, and also rises to the right. Now the difference then is, what if we have a negative? Well, if you think about it, it has an x-axis reflection. So on either end, it's going to fall. Because you got to flip this graph upside down. And so you can say the same thing about the next one. Fall, fall, and then this one, rise, and rise. So the premise that you're trying to get out of this is that if you have a even degree polynomial, positive on both ends, it rises, and if it's negative on both ends, it falls. And that x-axis reflection should make sense to you. So as you look at the next several, again, your highest exponent on all of these is an odd number. I'm just doing 4 at a time. Then I might have you do some on your own, then I'll show you the answer key. And the leading coefficient, again, is the coefficient in front of the highest exponent. So if we sneak the highest exponent somewhere in the middle, then the leading coefficient would be the coefficient in front of that highest exponent. Let's see, negative, negative. Clearly I forgot to write one down. So let me give you a quick visual of what's happening here. And it actually works for linear functions as well. Linear functions are just a straight line that typically go up and to the right, y equals x. But you can also have something like this, and the degree, like if it's a third degree polynomial, that just means it'll probably have 2 turning points. It doesn't have to, by the way. If it's a fifth degree, it'll have 4 turning points. But no matter what, if it's an odd degree positive leading coefficient, it falls to the left and it rises to the right. Sometimes I use the phrase odd opposite. I don't know if you've ever heard that before, but it has the opposite end behavior. Whereas if you think about the negative leading coefficient, again, we have an x-axis reflection, so it flips everything upside down. So instead of falling to the left, it rises to the left and falls to the right. So I think the next several problems are intermixed. So I'm going to ask you to hit pause. Try these on your own, and I'm going to share the answer key here shortly. So you can see where we left off and fill in the rest of the chart. And again, just double check that you're getting everything correct. And yeah, hit pause before I move back to the previous problem, the rest of the notes. Now, again, I'm not sure how you learned this in Algebra 2, but if you're following the notes, and how I would explain this is even degree functions, they go in the same direction, so a positive leading coefficient, they both go up on either end, and odd functions go in opposite directions. So if it's a positive leading coefficient, it goes up and to the right and down and to the left, versus a negative leading coefficient goes down and to the right and up and to the left. Now, the notation you're going to see me write from this point forward, so that may have been how you learned in Algebra 2, I'm not sure, or you may have learned it this way in Algebra 2, which is actually how I want you to write it. So if I'm talking about left end behavior, notice that all of the left side is saying that x goes to negative infinity. X goes to negative infinity. And that should make sense, because what sign do you use if we're going to the left? A negative for x. And to the right, we use positive for x. So then these are your rules that you can deduce from this. Is a positive leading coefficient that's even, they go up on either end. So they both go to positive infinity for the function. And if it's negative with an even, negative leading coefficient, even degree, they're both going down. So notice we have the negative sign for those. And then odd, this is the rule, it's just now we're writing it in a new way. As x goes infinitely to the left, the function goes infinitely down. That's a negative infinity. Infinitely to the right, the function goes up, infinitely up. And then odd, with a negative leading coefficient, flips that. So as x goes infinitely to the left, the function goes infinitely up. As x goes infinitely to the right, the function goes infinitely down. So again, pause the video if you need to write anything down. So I'm going to go back to the notes. So we're piecing everything together. Okay, I'm not telling you anything about the function, but as you look at, we have a 0 at -3, but it changes concavity there. So it's a point of inflection, which means it has a multiplicity of 3. We also have a 0 at 1, but it goes straight through, crosses the x-axis, so that has a multiplicity of 1. So as you add these together, so like an equal sign there, 3 plus 1 is 4. So that tells me it's a quartic. And notice that my end behavior, they're going in the same direction. So does my answer here match this? I guess I should have wrote like 4th degree. But the type of function is called a quartic, which is what I wanted you to write. They're going in the same direction, so that confirms that we have an even degree. Now it's going infinitely down on both ends. So what does that mean for our leading coefficient? That means our leading coefficient must be negative. Now I like using this notation. The leading coefficient is less than 0. If you actually write out the leading coefficient is negative, that is fine as well. And so from there, your justification could be something as simple as x goes to, now this is kind of unconventional, but I'm trying to save some time and space, that you can write as x goes to positive or negative infinity, the function is going infinitely down. Some teachers will let you do this. I will let you do this as long as the end behavior is the same. So I won't let you do that if it's a odd degree, as we'll look at the next one. And some other teachers might not let you do that at all. So we do have one more thing, and if you pay close attention to the directions, a possible equation for the function. Let me change colors to really emphasize this, because I think this is new for you. I'm not sure if you did this ever in Algebra 2. But all I'm expecting you to do is piece everything together. So use the fact that we have a negative leading coefficient. Now I don't know what that leading coefficient is, so I just want you to write negative a. Kind of like an ax squared plus bx plus c. That a is just your leading coefficient. And then go ahead and write the zeros. So x plus 3, I got from right here. But with a multiplicity of 3, I better put cubed right there. And then also x minus 1. Now with a multiplicity of 1, I don't have to write to the first power. You can if you want. And that's all I'm looking for right now. Down the road, I'll ask you to multiply this out, use clues in the problem to figure out what a is. But that's a future problem. So moving on to the next one, let's confirm everything we know. Negative 2 just goes through, so it has a multiplicity of 1. 1, x equals 1, bounces, so that's a multiplicity of 2. So as you add that together, that's 3. You add in your multiplicity, so that's a third degree polynomial, telling me it's a cubic, which is confirmed by going in opposite directions. So the other piece I want you to recognize then is it's going left and up. So maybe write that first as x goes to the left. The function, let's rename it something else, not f, because I used f for the previous problem. Let's call it g. Is going up. You don't have to write positive in front. And as x goes to positive infinity, this function is going down. So that's my clue that the leading coefficient is negative again. And so as I ask you to write the equation, again I'm calling it g of x, just to change it up, negative some leading coefficient. X plus 2 had a multiplicity of 1, so I don't have to rewrite it. Remember, it's the opposite of your 0. And then x minus 1 has a multiplicity of 2. So again, pause the video, make sure you understand it before I move on, or just make a new video. I think I'm going to finish the next 2 problems before a new video. But again, just pause and try it on your own. There's nothing wrong with you trying this on your own first. So if it helps to make a table out of this, I don't know if it really does. But negative 3 changes concavity, so that's a multiplicity of 3 as it crosses. Just go straight through at 1, just go straight through at 2. So as you add your multiplicities together, it is a quintic. Whoa, not sure what just happened there. Because it's a 5th degree polynomial. Just a quick justification as to what is happening is stating the end behavior. I'll call this h of x now, just to change it up. Goes infinitely up, and as x goes to positive infinity, h of x is going infinitely down. So that tells me my leading coefficient must be negative, so call this h of x will equal negative a, x plus 3 cubed, x minus 1, x minus 2. There we go. Again, pause and make sure you understand. I'm trying to hurry and get this done before 3 minutes are up though. Notice that at x equals 1, it bounces. So that's a multiplicity of 2. Changes concavity over here. We're at another 5th degree. Quintic. Again, to save some time, I'll let you just say, I'll call this p of x. I'm really trying to hurry. I'm up against a timer. So that's a leading coefficient that is positive. Now I do want you to still write positive A.